In this video, we are going to look at derivatives of logarithmic functions. But before we do, I want to look at four fundamental rules. Rule 1. The derivative of natural log of x with respect to x is equal to 1 over x. Rule 2. The derivative of natural log of f of x with respect to x is 1 over f of x multiplied by f prime of x. Rule 3. The derivative of log base b of x with respect to x is equal to 1 over the quantity x times natural log of b. And this is where b is greater than 0 and b can't equal 1. So notice how the numerator is 1 and the denominator is x times the natural log of b. Rule 4. The derivative of log base b of f of x with respect to x is equal to f prime of x divided by the quantity f of x times natural log of b. And the restriction still applies. Notice how b is greater than 0 and b can't equal 1. So these are the four fundamental rules. Now, with that, the directions say to differentiate the function. So let's take a look at example 1. Now, in this example, g of t is equal to natural log of 3 plus t squared. So notice how the inside function is 3 plus t squared. So when I take the derivative, I'm going to get 1 divided by the inside function, which again is 3 plus t squared. And I'm going to multiply by the derivative of the inside function with respect to t. So in other words, I'm going to multiply by the derivative of 3 plus t squared with respect to t. And the derivative of 3 plus t squared with respect to t is 2t. So I'm going to put a 2t up in the numerator. And then I'm going to divide by the inside function, which is 3 plus t squared. So if we look up here, this says g prime of t is 2t divided by 3 plus t squared. And that's the answer to example 1. So in example 2, we have f of x is equal to natural log of x squared plus 3x plus 5 if I want the derivative. So I'm going to get f prime of x. Notice how the inside function is x squared plus 3x plus 5. So I'm going to take 1 divided by x squared plus 3x plus 5. And I'm going to multiply by the derivative of the inside function with respect to x. So in other words, I'm going to multiply by the derivative of x squared plus 3x plus 5 with respect to x. And so this is equal to 1 over x squared plus 3x plus 5. And I'm going to take that quantity times 2x plus 3. And so therefore, if I write my conclusion here, f prime of x is 2x plus 3 divided by x squared plus 3x plus 5. And that's how we do example 2. Let's take a look at example 3. Suppose f of x is equal to x times the natural log of x minus x. And I want to find f prime of x. Well, to take the derivative of x times the natural log of x with respect to x, I need to apply the product rule. So I'm going to write down the first function, which is x. I'm going to multiply by the derivative of natural log of x with respect to x. Well, that's just 1 over x. Okay, right here. Let's write that a little more clear. So I'm going to write x times 1 over x plus the natural log of x, that's the second function, times the derivative of the first function, which is 1. And then I'm going to subtract the derivative of x with respect to x, which is 1. So this is 1 plus natural log of x minus 1, which is equal to the natural log of x. And so therefore, f prime of x is natural log of x. And that's example 3. Now, this is a classic chain rule problem on example 4. If I have f of x is sine of the natural log of x, notice the outside function is the sine function. The inside function is natural log of x. So when I want f prime of x, I'm going to get cosine of natural log of x. And then think about peeling an onion. So I have to take that quantity and multiply by the derivative of the inside function with respect to x. So in other words, I'm going to multiply by the derivative of natural log of x with respect to x. And so this is cosine of natural log of x times 1 over x. And I'm done. And so therefore, f prime of x is cosine of natural log of x over x. And that's how we do example 4. Now, let's take a look at example 5. F of x is equal to natural log of 1 over x. So there's a couple ways we can approach this. Now, I can rewrite natural log of 1 over x as natural log of x raised to the negative 1. Okay. Now, I can pull that negative 1 out in front of the natural log and write this as negative 1 times the natural log of x. So we're just simplifying that a little bit. And so when I look at the derivative of f of x with respect to x, I'm going to get negative 1 times the derivative of natural log of x with respect to x. And that's just 1 over x, right? And so therefore, f prime of x is negative 1 over x. And I'm done. Let's take a look at example 6. In example 6, we have y equals 1 over the natural log of x. But I can write this as natural log of x raised to the negative 1. And I want y prime. So this is, again, the chain rule. So I'm going to move the negative 1 out in front. And remember that the inside function is the natural log of x. So I'm going to get negative 1 times natural log of x raised to the negative 2. But don't forget, you have to multiply that result by the derivative of the inside function with respect to x. In other words, I have to multiply by the derivative of natural log of x with respect to x. And so this is negative 1 over natural log of x raised to the second times 1 over x. So if I write down my answer here, I get y prime is negative 1 over x times natural log of x raised to the second, and I'm done. This is example 6. Let's take a look at example 7. Suppose g of x is equal to natural log of x times e to the negative 2x. I would use the properties of logarithms to rewrite this. And I would write this as natural log of x plus natural log of e raised to the negative 2x, just like this. And so, therefore, g of x is equal to natural log of x plus negative 2x times natural log of e. So the exponent is negative 2x, and we can pull that out in front of the natural log. But remember that natural log of e is equal to 1, I claim. And so this is g of x is natural log of x minus 2x. And therefore, I can comfortably take the derivative. So g prime of x, that's equal to the following. That's equal to 1 over x minus 2. Now, you may want to talk to your instructor, right? Your instructor might want you to get a common denominator, and the common denominator in this case would be x. And so I would have to multiply the second term in the numerator and denominator by x, like so. And so, therefore, g prime of x is equal to 1 minus 2x divided by x. And that's how we do example 7. So let's take a look at example 8. We have g of t is equal to the square root of 1 plus the natural log of t. Okay? And I want g prime of t. Well, that's going to be 1 over 2 times the square root of 1 plus the natural log of t. Okay? Because notice the inside function is 1 plus the natural log of t. And also, we don't want to forget that the derivative of square root of t with respect to t, this is very common, so this is one I would want to remember. The derivative of square root of t with respect to t is 1 over 2 times the square root of t. So that's where I'm getting this first piece from. And then don't forget, we have to multiply by the derivative of 1 plus natural log of t with respect to t. That's the derivative of the inside function, in other words. And so this is 1 over 2 times the square root of 1 plus the natural log of t times 1 over t. And then I'm just going to write this a little bit different. The way I would cap this one off is I would say g prime of t is 1 over 2t times the square root of 1 plus the natural log of t. And that's how we do example 8. Let's take a look at example 9. In example 9, suppose we have the following. Suppose y equals log base 5 of x squared plus 3x. So let's say we do that one. The inside function is x squared plus 3x, okay? And so I'm going to look at y prime. So I'm going to take 1 over the inside function, which is x squared plus 3x. But don't forget, I have to take x squared plus 3x and multiply by the natural log of 5. And then even after all of that, what I need to do is I need to multiply that quantity times the derivative with respect to x of x squared plus 3x. And then the derivative of x squared plus 3x with respect to x is 2x plus 3. So I get 1 over x squared plus 3x times the natural log of 5. And then I'm going to take that quantity and multiply by 2x plus 3. And then I'm all set. So let's write down our final answer here. So y prime, this is example 9. This is 2x plus 3 divided by x squared plus 3x multiplied by natural log of 5. That's example 9. Let's take a look at number 10. Suppose y equals log base 10 of secant x. Okay. Notice how the inside function is secant x. And then don't forget the derivative of secant x with respect to x is equal to secant x tangent x. Okay. We're going to need that in a minute. So y prime is 1 over secant x times the natural log of 10, because that's the base. And I'm going to multiply by the derivative of secant x with respect to x. So therefore, y prime is 1 over secant x times natural log of 10 times secant x tangent x. And then if you don't mind, I'm going to put that over 1. So notice how the secant x's go away. And then what we're left with is y prime is tangent x over natural log of 10. And that's how we do number 10. And let's take a look at number 11. So we got 2 more. Suppose f of s is natural log of s. Okay. And then I want f prime of s. The inside function is natural log of s. Okay. So I'm going to get 1 over natural log of s. And I'm going to take that quantity and multiply by the derivative with respect to s of natural log of s. And so this is 1 over ln of s times 1 over s. Therefore, f prime of s is 1 over s times the natural log of s. That's number 11. And let's do one more for this video. I want to do number 12. And on number 12, we have the following. Suppose f of x is equal to 2 to the x times log base 2 of x. This is a classic product rule problem. So I want the derivative of this. So I'm going to write the first function. That's 2 to the x. I'm going to multiply by the derivative of the second function. That's the second function here. That's 1 over x times the natural log of 2. I'm going to go plus. Then I'm going to go log base 2 of x, right? And if we recall, the derivative of 2 to the x with respect to x, that's going to be 2 to the x times the natural log of 2. And I'm going to leave it in this form, but one thing I would recommend is talk to your instructor to see how far your instructor would want you to simplify this derivative. Okay? And that'll do it for this video. This is a derivative of functions that involve the logarithm. So, okay, thank you.